So how does a cell get everything that it needs in order to survive? In the rest of 7.3, we're going to focus on a couple of different processes, diffusion and osmosis. So let's just kind of go briefly over some of the terminology. There's lots of vocabulary in this kind of final section of 7.3. We're going to focus on some of that. So cells, all living cells, exist in some type of liquid environment. When we talk about the cytoplasm, in the sense it's almost this type of solution. So one of the things that we have to look at is the idea of a solute and a solution. So when we talk about these things, a solution is really any type of mixture of two or more. So it's a mixture of two or more substances. And a solute is really a substance that is dissolved. And this is important because this kind of gives us an idea of where is the cell getting kind of the nutrients and the other requirements that it needs to continue life. And part of that is that there's these different substances that are going to be dissolved and then therefore can enter the cell. So a solute is some type of substance that is dissolved in a solution, which is a mixture of two or more substances. This leads into this idea of concentration, which is going to be really important kind of moving forward. And concentration is really the mass of the solute in a given volume of solution, or mass divided by volume. And this becomes important when we start talking about diffusion and moving from areas of high concentration to areas of low concentration. So let's define diffusion. Diffusion is the process where particles tend to move from an area where they are more concentrated to an area where they are less. They're moving from a high concentration to a less concentration. That's diffusion, and this happens lots of kind of all over the place. When you think about getting close to the holidays and someone's making cookies in the oven, but yet somehow you smell it, in your bedroom on the second floor. So how does that occur? Well, through this process of diffusion, where these kind of gas particles are entering into the air, and because of diffusion, they're moving from where they're highly concentrated to areas of low concentration. And that's why you can kind of smell it throughout the house as it permeates and tries to almost equalized. So diffusion is based on this principle of equalization. So think of kind of like the old balance. If there's an area too high, it's going to try and move to areas where it's lower to kind of balance it out. And when a concentration of the solute is same throughout, it is reached equilibrium. And this is kind of the goal. This is what everything's trying to get to. It's trying to get to this idea of equilibrium, balancing out areas of high concentration and low concentration until they're the same concentration, which is equilibrium. All right, so we just kind of look at diffusion across the cell membrane. Remembering back to our cell membrane is what's going to regulate that. And we have our lipid bilayer here. And what happens is we have an area of all these solutes, these blue dots, in a solvent, which would be the black. And what happens is there's an area of high concentration, and diffusion tells us that things are going to try and equalize out. They're going to try and balance so the concentration is the same. So they're going to move from an area of high concentration to an area of low concentration. And so this is what eventually happens, is you get some of these solutes in the solvent moving across the lipid bilayer to equalize. And this is what kind of happens at the end. So you see, as kind of time goes on, eventually we would anticipate that the concentrations here are the same. All right, so the last little bit about diffusion is diffusion depends upon random particle movement. So there's not really any rhyme or reason other than the sense that they're trying to move from areas of high concentration to areas of low concentration. And because there's just kind of this random movement, substances are going to diffuse across membranes without requiring the use of energy. And I started because that's going to become important when we start talking about some of the differences of diffusion and osmosis and active and passive transport. We'll get more into that into the next section. But the key here is it's that random movement. So there's not any rhyme or reason for what's going on. And that's it for part 1 of section 7.3.